In the last lab, I solved this problem using Thevinins theorem. Any doubts in this Thevinins theorem? So let me repeat this one. Okay, let's do the same problem using Norton theorem. So here, see the circuit. So here, RL. If R equal to 10, what is the current flowing through RL? That is the first problem. Next, in the second case, if RL equal to 70 ohms, if RL equal to 70 ohms, what is the current flowing through R? That is the second case. So here, first, here we are going to find the current using Norton's theorem. So here, except RL, remaining circuit, we have to get the Norton's equivalent. So here it is shown in the dotted box here. dashed box. So for this, first Norton's theorem, what we have to do? We have to find out the short circuit current. So here, remove RL and join A and B. Here, this is the circuit. So here, RL is removed and replaced by a short circuit. So here, if you see the difference, so RL is replaced by a short circuit. So in Norton's theorem, you have to put the circuit current. So you find the current in many ways. Here using KVL, I got the current ISC as 4 amperes. So all of you draw the circuit and find out the current IC. This all of you draw the circuit. Ay, कुछ लो मुझे काम है Have you read what is the short circuit current? Yeah, what is the short circuit current you got? Yeah. So I got the short circuit current as 4 amperes. So 4 amperes is the Norton's current, and 10 ohms is the Norton's resistance, which is equal to Thevenin's resistance. And if RL equal to 30 ohms, I got a current flowing through RL as 1 ampere. Same. Now if RL equal to 70 ohms, I got current flowing through 70 ohms as 0.5 amperes. So here you can see the same value when done using Norton and also when Thevenin's. So finding the short circuit current, we have to write the KVL equation for these two loops. So let us write the KVL equation for first loop. What is the KVL equation for the first loop? So here 48 Here, let me write the Kvl equation for the first loop. So 48 voltage rise, 48 minus 3I1. Okay, 48 minus 3I1. And how to take here? Minus 32. Minus 4 into I1 minus I2. So here this is the Kvl equation for the first loop. So first loop, this is the Kvl equation. So 48 minus 3I1 minus 32 minus 4 I1 minus I2 minus 1I1 is equal to 0. Any doubts in this equation? Just understood the Thevinins theorem? Yeah, please go on. Yes, 119. So here this is the Kvl equation for loop 1.
Sir, voice is breaking, sir.
Voice is breaking.
Yes, sir.
See here, in Norton's theorem, in Norton's theorem, Norton's equivalent circuit. This is a complex network. This is a complex network. A and B are two terminals. Two-terminal complex network can be replaced by a single current source in parallel with the resistance R. So here, the current source, the value of the current source is the short circuit current. That means if the terminals A and B are short circuited, the current flowing from A to B is the short circuit current. So the current flowing from A to B is the short circuit current. So that the short circuit current is the value of the current. So the value of the current source is the short circuit current. So here this complex network is replaced by a Yes, you can see here the complex network is replaced by simple equivalent circuit consisting of single current source in parallel with the resistance Rn. The short circuit is obtained by short circuit terminals A and B. Here. The terminals A and B are short circuited. The current flowing from A to B is the short circuit current. And the value of Rn is same as that of the Thevinins theorem. Now here I am going to get the Thevinins equivalent for this part of the network. That means except RL, remaining part of the network, I am going to get the Norton's equivalent circuit. So first, so here this is the terminal A. See here, this is the terminal A, and this is the terminal B. See here, what I done? So I replace the RL with the short circuit, and I am going to find the current flowing from A to B, the short circuit current. For that, I have to use KVL. So here I applied KVL for this first loop. This is the equation. Next, I am going to apply the KVL for the second loop. So for this, I am going to apply the KVL. So here you can see here. See here. So let me start from this voltage source. So minus 2 means, so we have to traverse in the direction of the loop current I2. So minus to plus means voltage rise. That means 32 minus 8I2 minus 4 into resistance. I2 minus I1 is equal to 0. These are the two loop equations. So this is for the first loop, this is the equation, and for the second loop, this is the KVL equation. To solve these two equations, you are going to get I2 as, so I already done. So I2 as 4 amperes. So you are going to get I2 as 4 amperes. If you solve these two equations, you are going to get I2 as 4 amperes. So I2 is equal to ISC. See here. So after getting ISC, next you have to find the equivalent resistance, which is equal to Norton's resistance. See here. So that you are going to get as 10 ohms. So if you substitute RL equal to 30, you are going to get IL as 1 ampere. If you substitute RL equal to 70, you are going to get IL as 0.5 ampere. Now here, let us Norton's theorem for circuits containing voltage sources and current sources. is completed. So determine the current flowing through 11 ohm resistor in the network shown below using Thevinins theorem. So here you have a voltage source and a current source, and you have to find the current flowing through 11 ohms. So for that, first you have to find the voltage VTH. Now here this becomes the terminal A. Now this becomes the terminal A, and this becomes the terminal B. So here AB, voltage across AB is VTH. So what is the value of VTH you got? Respond. So VTH you are going to get 17 volts. How many of you got 17 volts as VTH? So VTH you are going to get as 17 volts. VTH equal to 17 volts you are going to get. So here, so how to find VTH? So here you can apply Kcl at this node. Let V be the voltage at this node. So V minus 15, V minus 15 by 6 plus V by 3, that is sum of the outgoing currents is equal to sum of the incoming currents, which is equal to 6. So here, so follow this one, KCL, applying KCL at this node. This is the node. At this node, we are going to find the voltage by using KCL. So we are going to apply KCL at this node. So here, V minus 15 by 6 is the outgoing current, V by 3 is the outgoing current, and the incoming current is 6. Sum of the outgoing currents is equal to sum of the incoming currents. So here there will be no current as it is open. So here you have only 3 currents, 2 outgoing and 1 incoming. So here you are going to get the voltage V as 17. V equal to 17. So VTH you are going to get as 17 volts. So once VTH you got, then you can find the RTH. So here how to find RTH for this one? So for finding RTH, see here. Is it clear VTH? Do you have any doubts for finding VTH? Yeah, please respond.
No, sir.
Okay, VTH you got as 17 volts. Now you have to find RTH. So for finding the RTH, we have to replace the energy sources by their internal resistances. So here internal resistance for voltage source is 0. So here I am drawing here. So voltage source is replaced by short circuit, and here 6 ohms. So for the sake of simplicity, I am not writing the symbol ohm. So it is a good practice to write the ohms. So here A, so this is the terminal A, this is the terminal B. So his current source is replaced by a open circuit. So here current source is replaced by open circuit. Okay. Voltage source is replaced by short circuit. Now here find the find the resistance across the terminals A and B. Now here 6 and 3 are in parallel. So 6 into 3 by 6 plus 3. So 2 ohms, 2 plus 4. So here RTH, you are going to get RTH as RTH will be equal to 6 ohms. So here this is the Thevinins equivalent network. So here this is the this is the Thevinins equivalent network, and here these are the terminals A and B. Okay. So VTH equal to 17 ohms, 17 volts. VTH equal to 17 volts. RTH equal to 6 ohms. So VTH, whatever the VTH 17 volts, and RTH, this is the RTH equal to 6 ohms. So here I am going to find the current flowing through 11 ohms resistor. So I am replacing this entire circuit except 11 ohms with the Thevinins equivalent network. So this dotted portion I replaced with this simple equivalent circuit consisting of VTH 17 volts, RTH 6 ohms. Now here I can find out the current flowing through 11 ohms. So here voltage divided by resistance. So 6 and 11 are in series. So 17 by 6 plus 11 I am going to get as 1 ampere. So here this is an example for the network which is consisting of one voltage source and one current source. So any doubts in finding the VTH and RTH? So here in Thevinins and Norton's theorem, so for finding the RTH we have to replace the voltage source by short circuit and current source by open circuit. So current source is replaced by open circuit. So here next we can do the same problem using Norton's theorem also. Shall I proceed for Norton's theorem? Yeah, respond.
Yes, sir.
Is it clear? Tell me. If it is clear, then I will
Sir.
proceed to Norton's theorem. The same problem I am going to do using Norton's theorem. Yeah, please respond.
Yes, sir. You can proceed.
Okay. So those who have tried to do the same problem using Norton's theorem. So I will show the circuit diagram, same circuit. Yeah. క్లాస్ అయిపోలే. క్లాస్ అయిపోలే, డబ్బులు కావాలంటే మళ్ళా. Okay, here if I want to do the same problem using Norton's theorem, finding RTH will be the same. RTH or RN both are same. I have to find out the short circuit current. So let me do the short circuit. Let me find out the short circuit current. Silent. KCL here. Applied KCL at this node. V minus 15 by 6 is outgoing current. V by 3 is outgoing current. Minus 6 amperes because incoming current. And V by 4 is outgoing current. So solve the equation and get the value of V. So what is the value of V you got? So any doubts in this equation, KCL equation? Yeah, please respond.
Sir, screen sharing is not visible.
KCL is not visible.
Screen sharing, sir.
Oh, okay. Wait. Okay, are you able to see the screen now?
Yes, sir.
Okay. So here, the same problem I am using the Norton's theorem. In Norton's theorem, I replaced the 11 ohms with a short circuit. So I short circuited the terminals A and B and finding the current, short circuit current. So for that, I am using KCL. So I applied KCL at this node. So V minus 15, V minus 15 by 6 plus V by 3 minus 6 plus V by 4. So here this is the Kcl equation and solve the equation and get the value of V. Yeah, make it fast. Solve the equation and get the value of V. So once you get the value of V, so find the value of V. After getting the value of V, I can find the ISC. ISC equal to V by 4. ISC will be equal to V by 4. So find the value of V. So if I get V, then I can get ISC, and I can substitute the value of ISC here. So even in fractioning also it is okay. Yeah, find the value of V. Anyone? Yeah,
14
please.
by 3, sir.
14 by 3.
Yes, sir.
Others also got the same one. Fourteen by 12. What shall I do? Shall I have to do? Anyone got 14 by 3? Same answer? See here. To take the LCM and do. So let me do. So I got V as 34 by 3. So I got V as 34 by 3. Thirty-four by 3. Have got the same answer. V equal to 34 by 3. And IS equal to V by 4, which is equal to 34 by 12. So if I put IS equal to 34 by 12, now current flowing through 11 ohms. If I want the current flowing through 11 ohms, here current division rule. So current flowing through 11 ohms will be equal to IL, that is IL, I am taking as IL. That is current flowing through 11 ohms. Current flowing through 11 ohms. So a total current 34 by 12 into opposite resistance 6 by sum of the resistances 6 plus 11. So you are going to get so 34 by 12 into 34 by 12 into 6 by 17. So you are going to get this as 1 ampere. I got the same answer here also. The same answer. So here the dotted portion, this is the dotted portion here. See here, same problem. Instead of Thevinins, I am using Norton's here. Thevinins already completed. If you want to use Norton's, so for this dotted portion, I have to get the Norton's equivalent. So for here, for getting the Norton's equivalent, I have to find out the short circuit current. So I have to find out the short circuit current. So here, A and B are the two terminals. So here, A and B terminals are short circuited, and I am going to find out the current, short circuit current. So here I used KCL, I applied KCL at this node and got the ISC as 34 by 12 amperes. So here I got the ISC. ISC is the Norton's current. So here ISC I put here. Next, I have to find the equivalent resistance across the terminals A and B. So here this one same. So here RTH and RN both are same. So I got RTH as 6 ohms, which is equal to RN. So RN equal to 6 ohms. Next, I replaced the 11 ohms as it is. Here 11 ohms. So here the dotted portion is replaced by Norton's equivalent, which contains a current source in parallel with a resistance Rn. The value of Rn is equal to RTH. Now I am going to find out the current flowing through 11 ohm resistor. So here total current is 34 by 12. So this current gets divided here. 6 and 11 are in parallel, so current gets divided. So here I am using the current division rule. So 34 by 12.
సార్ ప్రీవియస్ ప్రాబ్లమ్ సిరీస్ వచ్చింది, ఇప్పుడు ప్యారలల్ ఎలా వచ్చింది సార్?
What?
ప్రీవియస్ ప్రాబ్లమ్ సిరీస్ తీసుకున్నారు కదా సార్, ఇప్పుడు ప్యారలల్ ఎలా తీసుకున్నారు?
No, this is Norton's. This is Thevinins. VTH, RTH. So parallelly I am showing here. Same problem I am solving using Thevinins and Norton's. So in Thevinins theorem, we are replacing the two-terminal network with a VTH and RTH. VTH in series with resistance RTH. This is Thevinins equivalent. Norton's equivalent is this one. This one is the Norton's equivalent. It contains a current source in parallel with the resistance Rn. The value of Rn is equal to RTH. Here, this is Rn. Let us put Rn. This is Rn. Now here, this is the current division rule. So total current divides in these resistors, two resistors. So if I want the current flowing through 11 ohm resistor, you have to take the opposite resistance, that is 6 ohms divided by sum of the resistors, 6 plus 11. So that total current 34 by 12 into 6 by 6 plus 11. So here more resistance means less current. So in that way also you can remember here there is a proof for this one. So here one important point is we take a Thevinins theorem. So the two terminal network. What are the two terminals? A and B are the two terminals. A and B are the two terminals. The two terminal network is replaced by a voltage source in series with the resistance RTH. And I am going to find out the current flowing through 11 ohm resistance. Coming to Norton's theorem, so the two terminal network is replaced by a, see the dotted box here. The two terminal network is replaced by a current source in parallel with the resistance RL. So A and B are the two terminals. So in Thevinins theorem, we are going to replace the network, complex network with a simple equivalent circuit consisting of a single voltage source in series with the resistance RTH. A and B. So left side of the A and B. You take A and B are the two terminals. Left part of the left side of the A and B terminals, you have this circuit. You have this network. See here, A and B are the two terminals. Okay. So left side of this A and B, you have this part of the circuit. This can be replaced by a voltage source in series with the resistance RTH. Next, this is Thevinins theorem. And coming to Norton's theorem, so we are replacing the circuit complex network with a single current source in parallel with the resistance Rn. The value of Rn is equal to RTH. Okay, do you have any doubts in Thevinins theorem and Norton's theorem? Okay, let me take the attendance. Number 61. Yeah, please respond. 61.
Yes, sir.
Okay, 62,
Present, sir. 62.
53,
Present, sir.
64,
Present, sir.
65,
Present, sir.